If we eradicate the limits, the most spellbinding divine body I perceive is the one that may be exceptional in our sky. It is this one, insect squeeze. It's a huge red, very monster star, and on the off chance that you were to situate it where our sun is, it would stretch out completely out to the orbit of Jupiter. This enormous, incredibly shaky, and nearly detonating star is not quite so clear as it might appear to be in the universe. These gigantic events, like the most limit supernovae, could shake all that we notice and even things we don't. However, we can't see it. Obviously, Betelgeuse is thought of as a symbol of a red giant star, regularly a lot bigger than our own. Brian Cox, alongside other cosmologists, believes it could detonate in a cosmic explosion before long. People have grown increasingly worried about what will occur since the James Webb Space Telescope has been catching momentous pictures of the star. When exactly will scarab juice emit into a cosmic explosion, and how critical will the effect be on the planet? We should dig into a star in the Grand Orion group of stars, which shines so brightly that even ancient civilizations saw it. The amazing star Scarab Jew dwells on the eastern shoulder of the Orion heavenly body. It ranks as the second largest star in Orion, and its name gets from this area, marking it as a shoulder star. Creepy Crawly Jew is likely one of the most brilliant stars visible in the night sky. Notwithstanding its splendor, the star produces a strange red shade, which, as we will investigate, signals potential danger. Humanity has long studied Bug Jew. Greek cosmologist Tmy noticed it long ago. Around then, the first thing people perceived about stars was their variety. Tmy noticed that the star appeared like a ruddy orange shade, a disturbing sign. As of late, scientists have been concentrating on the star with even more accuracy, and they now have a much clearer understanding of what makes it so strikingly iridescent. One of these factors is that the star goes through significant variations in brilliance, fluctuating by as much as 0.6. Bug Jew is a variable star, meaning its brightness changes occasionally. In 2019, specialists found some new behaviors of the star that had never been seen before. Despite the fact that insect juice didn't quit sparkling totally, its luminosity significantly diminished. It diminished to a degree of around 1.6, inciting specialists to investigate why such an abnormality was happening in perhaps one of the most brilliant stars overhead. They were expecting to track down an explanation for why Betelgeuse was acting so whimsically. According to their findings, Betelgeuse could detonate as a cosmic explosion out of the blue. Brian Cox, a renowned scientist, shared this disturbing evaluation. As a recognized professor of particle physics at the University of Manchester and the Royal Society Professor for Public Engagement with Science, his perspective carries weight. He also presents popular science network programs and writes books, making his viewpoint well regarded. Brian Cox explained that Betelgeuse seems like a ticking time bomb, one that could emit with nearly no warning. To help this claim, the James Webb Space Telescope has provided significant evidence. Although some quirks about Betelgeuse have raised many questions, such as, why does Bug Jew act so oddly in terms of its inconsistency with the new data? Bug Jew has earned its place as a contender for a cosmic explosion. However, specialists still don't know when the blast will happen. The fact that Betelgeuse's mass is nearly 2 times that of the Sun supports this arrangement. Generally, stars with at least a few times the Sun's mass are viewed as potential supernovae candidates. The plot thickens, however, because researchers have used various tools to investigate Betelgeuse, for example, the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory to uncover secrets surrounding the star. What they've uncovered is still shrouded in mystery. Betelgeuse was born on August 31st, a long time ago, and since then, the star has been emitting strange signals that keep its future uncertain. What did they find? They identified exceptional light waves exuding from the star, which raised further interest. But this wasn't the only odd event. It takes us back to the fact that Bug Jew is a variable star, fluctuating in brilliance. There were reports that Betelgeuse had normal obscuring episodes, likened to sunspots on our own sun, but the cycles were different. It shifts between bright and faint stages twice as quickly as it once did. Another odd sign that Betelgeuse is getting rowdy. Analysts noticed that in February 2021, the star's diminishing cycle reached a brightness band of +1.61. This was not long after the star had experienced a massive dimming event, marking the start of its unusual behavior. And that's what raised alarms. Betelgeuse may be approaching the end. The huge dimming between 2019 and 2020 reached its lowest level, causing many specialists to believe that the star would detonate within the next 100,000 years. However, when creepy crawly juice lit up once more after this remarkable dimming, things became even more confounding. Astrophysicist Andrea Dupree from the Harvard-Smithsonian Center for Astronomy noticed that the star was now 150% more brilliant than usual, making it the seventh brightest star in the sky. Scientists were shocked to see a red glow emerging from the southern part of the sky. What is happening just became more confusing. This development ignited various speculations about the cause of Betelgeuse's extraordinary dimming. It's crucial to note that not every star emits the same red glow that creepy crawly Jew does. This glow marks Scarab Jew as a red giant star, which is the last phase of a star's life, just before its demise. This red tone is the result of a surface temperature around 3,500 Kelvin, significantly cooler than the outer layer of the Sun, which is near 5,500 Kelvin. Since Scarab juice is cooler than the Sun, it emits less energy per unit of surface area. Even though it is much larger and on the verge of detonating, we should also consider the remarkable dimming event that Brian Cox questions. Does it, in fact, mean Betelgeuse will go supernova? The truth that Scarab Jew is already in its red giant stage suggests that it is approaching its inevitable end as a star. A star in this stage will often dim as it dies, and this is something researchers can identify. However, Betelgeuse's recent unusual behavior has caused scientists to focus even more on observing it. Today, different telescopes are focused on this puzzling dimming event, trying to gather more insights. Things continue to get more intriguing since specialists still don't have a deep understanding of Betelgeuse's behavior. Using cutting-edge instruments, researchers are watching the star closely. The James Webb Space Telescope has been one of the most important tools since its launch in 2021. Helping space experts gather new significant information about Betelgeuse. The telescope's pictures of the star's amazing darkening have shown that the event caused a massive coronal mass ejection, about 400 billion times larger than a normal coronal mass ejection. The James Webb Space Telescope can also notice things that are invisible to the human eye, such as specific light frequencies, making it an invaluable resource. Specialists have noticed dust clouds forming on the star's surface, which seem to resemble leaves in space. An odd but fascinating finding. Regardless of the truth that bug juice is without a doubt moving toward its downfall, researchers continue to search for signs of when it will finally explode. As nobody knows the exact moment, creepy crawly juice is believed to be much larger than the Sun, and specialists anticipate this brilliant red star to shine for the next decade. However, given the star's abnormal behavior, it is difficult to say whether this estimate will turn out as expected later. After the critical dimming event, for the present, researchers don't expect that creepy crawly juice will detonate in the near future. But when it does, it will be the first cosmic explosion seen in modern times since Johannes Kepler's observation in 1604. Researchers don't believe it will happen soon because they are still trying to figure out the star's erratic behavior. Despite this uncertainty, when bug juice does eventually explode, it will be an incredible and fascinating galactic event. When it finally goes supernova, it will release a tremendous amount of energy, momentarily shining brighter than the entire galaxy and visible even from Earth, bright as the full moon. However, the cosmic explosion will be a stunning, infinite event. It won't pose any immediate danger to Earth since Betelgeuse is over 600 light-years away. Still, it will provide a significant opportunity for researchers to study the final phases of a giant star's life and the phenomena related to such a volatile event. Insect juice's inevitable downfall isn't simply a scientific interest but also a sign of the immense and unpredictable nature of the universe. Stars like Betelgeuse play a vital role in the life cycle of galaxies, enriching the universe with elements essential for the formation of new stars, planets, and possibly life itself. The death of such a star isn't an end, but a transformation as it releases heavy elements that will seed new stellar systems. Meanwhile, researchers continue to observe creepy crawly Jew, piecing together the riddle of its future with each new discovery. The mystery surrounding it grows deeper, expanding our understanding of the universe with each piece of the puzzle revealed. Perhaps, in the years to come, we will witness one of the most unprecedented events in the universe: the transformation of bug juice from a gigantic red supergiant into a stunning cosmic explosion. Until that time, the sky will remain a canvas of marvel, with Betelgeuse shining brightly as a sign of the temporary nature of life in the universe. Betelgeuse's transformation into a cosmic explosion is an event that will capture the attention of space experts and skywatchers alike. Despite the uncertainty of when exactly this change will occur, the star's current instability has sparked a wave of hypotheses about its future. The advanced instruments and technologies available to us, such as the James Webb and Hubble space telescopes, have provided astronomers with phenomenal insights into the behavior of this remarkable star. As Betelgeuse's brightness changes and its erratic fluctuations continue, researchers are carefully studying the data in hopes of understanding what triggers these shifts. The star's extreme variability could be a precursor to the violent explosion that will ultimately mark the end of its stellar life. Whether or not bug juice will detonate within the next couple of years or in a much longer time frame remains uncertain. One thing is clear: the universe is filled with celestial surprises, and creepy crawly juice's eventual end will be a spectacle that brings new opportunities for discovery. Throughout the centuries, cosmologists have observed and studied countless stars, but few have garnered as much attention as Betelgeuse. Its enormous size, variable brilliance, and surprising color have made it a subject of intense research. As a red giant, creepy crawly juice is already in the final stage of its life cycle. The star's immense size means that it will eventually exhaust its nuclear fuel, leading to its inevitable collapse and subsequent explosion into a supernova. This explosive event will release an astounding amount of energy, dramatically altering the surrounding galactic environment. Despite the many uncertainties surrounding the precise timing of Betelgeuse's supernova, astronomers agree on one thing: the star's impending destruction will be one of the most significant cosmic events of our lifetimes. The data being collected by the most advanced telescopes today is helping to unravel the mysteries of the star, providing crucial information about the processes that occur during the final stages of a star's life. By studying Betelgeuse's behavior, researchers can gain further insights into the broader mechanics of stellar evolution. Moreover, the explosion of Betelgeuse will likely leave behind a lasting impact on the surrounding space, enriching the interstellar medium with heavy elements that will eventually be incorporated into new stars, planets, and possibly even life forms. This process of creation and destruction is a fundamental aspect of the life cycle of stars, and Betelgeuse's supernova will be a perfect illustration of this colossal process. As we continue to observe creepy crawly Jew and other stars in similar stages of development, cosmologists are using cutting-edge technology to better understand the forces at play. The James Webb Space Telescope, with its unparalleled ability to observe distant objects in the universe, is providing an abundance of data that will shape our understanding of celestial dynamics. The images and measurements captured by this telescope are helping to shed light on the intricate mechanisms that drive a star's evolution, from its birth to its ultimate demise. Although the death of a star may seem like a catastrophic event, it is, in fact, a crucial step in the ongoing process of stellar evolution. The elements released during a supernova contribute to the formation of new stars, planets, and even life. In this sense, the death of Betelgeuse and stars like it is not an end, but rather a transformation that facilitates the birth of new celestial bodies. As such, Betelgeuse's supernova will play a significant role in the continuing evolution of the universe, contributing to the creation of the building blocks for future generations of stars and planets. Until the day scarab juice finally detonates, cosmologists will continue to observe and study its behavior, piecing together the clues that will help them predict its future. The star's unpredictable dimming and brightening cycles, as well as its other surprising behaviors, make it a fascinating subject of study. With each new discovery, researchers are learning more about the processes that govern the life cycle of stars and, by extension, the evolution of the universe itself.